Good afternoon and welcome to the 23rd annual exhibit of Hydrogen and Fuel Cell Technologies. I am going to dispense with a lot of the information we generally give because we have an important presentation today with a very original format. We'll be doing elevator pitches from electrolyzer manufacturers. They'll be presenting their technologies, and I think the most interesting thing about this format is that afterwards they all join us on the stage to discuss and debate the prospects and the importance of this technology in recovering renewable energy, in making our economies less carbonated, and in improving the environment, among other things, because it's also an industrial gas, so we are moving from one end of the hydrogen use to the environmentally significant changing factor in our energy economy. This is a very important technology because there is no other technology that can store the quantity of renewable energy available to us. We cannot harvest the wind energy available. In the States recently, in California, they have reached a ceiling in the solar industry because they simply cannot store and use energy when it's necessary. So these are the guys that are going to be changing things for us. They'll be providing hydrogen for the automotive industry, for delivery trucks and buses and so on, and we're all waiting for information from them. When is this going to happen, and what role will electrolysis play? The different technologies involved, the disadvantages or advantages of various technologies. This is all part of the discussion after the presentations. First, the presentations, and without further ado, I'll be inviting the first of 5 guests on the stage. It's Szymanski, who's Director of Business Development at Nell Hydrogen. They produce electrolysers, of course. Please welcome with me, Szymanski.
Thank you. First, I have to say that I've done tech forum presentations a number of times before, and it's funny to see Nell Hydrogen under my name this time, because every other time it's been as Proton On-Site, which I'll explain a little bit. I'm going to recycle a few slides from a presentation I did at an offshore wind conference in the U.S. recently, because I think it really kind of resonates here in Europe, where most of the offshore wind is installed. So I'm just going to quickly go through some slides just to kind of talk about how electrolysis really can be an enabler for large-scale offshore wind. Quickly, for those who may not have heard that, Proton On-Site was acquired last year by Nell Hydrogen, and the combined company between our U.S. operations and our Norway operations makes us the largest electrolyzer company in the world. So just a few factoids about the company. I represent the subsidiary in the U.S., Proton On-Site, but we are one big happy family now, representing both our alkaline and PEM electrolyzer technology. So really, there's kind of 3 main operating units that we have as part of Nell Hydrogen. There's the alkaline electrolyzer business unit based in Norway that dates back to 1927. There's the Proton business unit, which was founded about 22 years ago now in Connecticut. And then the H2 Logic company was acquired in 2015, and they make the packaged hydrogen fueling systems in Denmark. And we recently announced that these fueling stations have gotten UL listing in the United States. It's the first company to offer a UL listed fueling station product in the world. So, just to kind of in the context of offshore energy generation, when we look at different technologies, hydrokinetic, ocean thermal energy conversion, and offshore wind, what do they all have in common? Well, among other things, the challenge of how you cost effectively store and export energy at a large scale. Laying cables across the seabed is not a trivial thing. And the idea, and also it doesn't give you the ability to store anything, but the ability to store energy in the form of a fuel is something that adds a lot of capability and enables offshore energy platforms. So I thought this was kind of interesting. Lockheed, which is a huge, U.S.-based conglomerate, has been looking at ocean thermal energy conversion for many, many years now. And this is a concept they came up with in 1977, making hydrogen on the offshore platform, converting it to ammonia, and transporting it on tanker ships. So this is not a new idea, and it's something that's gaining a lot more credibility as we look more and more at how to export large amounts of renewable energy. So, this is just a map of wind, offshore wind, in the summer and the winter. In the it's showing it, the winter in the northern hemisphere at the top, and the summer in the northern hemisphere at the bottom. And as you can see, there's very significant seasonal variations between summer and winter in offshore wind. So how do you address that? One of the things that I like to point out when people talk about cost of energy storage, we talk about the levelized cost of energy storage. And, what I like to point out is, batteries, play at a relatively small, short discharge time. Really, what we're talking about on the right, those are all forms of hydrogen energy storage enabled by electrolysis. Hydrogen, liquid organic hydrogen carriers, and ammonia are all forms of hydrogen energy storage, and they all offer a low-cost solution at long discharge times. So large-scale renewable hydrogen production is not new. Okay, our company has been doing it since the 1920s. These are 235 megawatt installations in Norway operating off hydropower. So this is not something new. It's something that is well proven. And recently we showed a gigafactory concept for a 400 megawatt project. We've done a detailed design study, including costing, and we're looking at a CapEx ratio of about $450 a kilowatt for a 400 megawatt plant. So that starts to get pretty interesting when you start looking at large scale. And on the PEM side, I like to point out that there's very significant cost reduction opportunities in what we're doing on the PEM side in the US, including platform scale-up, okay, in terms of balance of plant, the advanced stack work that we're doing, increased current density. That helps to reduce cost by enabling us to keep the stack smaller. And power electronics are still a significant cost opportunity. So when you kind of add those up, we can easily more than cut the cost of the electrolyzer system, the PEM electrolyzer system, in half by attacking these areas of development. And that's it. Thank you.
On the stage. Next up on the stage, we have Dr. Masami Takenaka. He's from the Clean Energy Project Managing Executive at Asahi Kasei, Europe. Welcome, Masami. Oh, yeah. The slides.
Thank you, Brian, for introduction me. And my name is Masami Takenaka. I am the Managing Executive and Project Leader of Clean Energy of Asahi Kasei Europe. Let me explain about our alkaline water electrolysis system, which is based on our chlor-alkaline technology. And let me introduce briefly about Asahi Kasei. As you can see, we are one of the biggest chemical company in Japan, and we are also a diversified company. We can operate in 3 business sectors, which are, one is materials, and one is homes, and also healthcare. And our net sales is about 16 billion euro per annual, and also we have about 33,000 employees all over the 15 countries. And then our major product, as you can see, our products range from basic chemical materials to electronics and healthcare component. And we are also a strong market leader in the world and in the region, as you can see here. Then we have our operation in Europe, and Asahi Kasei Europe was established in Düsseldorf in Germany in 2016, and now materials for automobile and medical and chemical industries are the biggest business now. And also, of course, we have to focus on our environmental related business in this country. So, next, I explain about our clean energy project. And the clean energy project of Asahi Kasei started in 2017. And our mission is to develop hydrogen business based on water electrolysis for realizing the society of clean. Sorry, you cannot see that. But we can create carbon dioxide-free hydrogen by using renewable energy and by using our electrolysis technology. And also, we can reduce the amount of carbon dioxide by chemical reaction with green hydrogen and carbon dioxide. Then we can make carbon dioxide-free methanol and carbon dioxide-free methane in order to make a contribution to reduce the amount of carbon dioxide all over the world. That is our mission. And Asahi Kasei's electrolyzer business has a long history, and we have first started in 1920s. We produced ammonia by using Haber-Bosch process. That is very long history. And also, since 1975, Asahi Kasei has supplied chloralkali electrolyzer. It's a very big system, and all over the world, and we are world number one supplier of chloralkali electrolyzer system and its materials. So we have a long history for electrolysis. And look at this, and Asahi Kasei's water electrolyzer has three features. Number one, that is large-scale capacity. It's 10 megawatt and 2,000 normal cubic meter per hour as a single unit. Of course, our technology is based on our chloralkali technology, so we can good at this large-scale capacity, so we can supply a lot of hydrogen quantity. So that is one first feature. And second is we have a highly efficient system. And you can look at see this direction shows high performance, and our electrolysis system has a very good performance compared with other systems. And also, the last feature is our system is compatible for unstable power supply like a wind turbine. So you can see our system can respond quickly to the fluctuated power like this one. So this is my final slide, and Asahi Kasei's business plan. Our anticipated market is one is power to gas, such as transportation and heating and electricity. And second is power to fuel for transportation. And also in Japan, we have successfully finished our demonstration at large scale over 12,000 hours. Then we are now operating at a large scale in Japan. So next time, so in Germany, we will start our demonstration in Helten. As you can see here, that is H2 Helten in Nordrhein-Westfalen in Germany. We will start this Friday our demonstration at middle scale, and also we are eager to get in the market from 2019. That's all. Thank you very much.
Good catch. I'm not sure who's next. Dr. Frank Allebrod, who's head of R&D at H-TEC Systems. Yeah, welcome.
Okay.
Take the stage.
Thank you very much for the kind introduction. Welcome to my talk about PEM electrolysis. Hydrogen energy is the enabler for different business opportunities for the electrical energy market. Different kinds of electricity can't be supplied to chemical industry. Through sector coupling, which is a big topic nowadays in the hydrogen sector, we can enable those markets for the electricity suppliers. It is not only, but very important, the storage of electrical energy and the reconversion into electricity through a fuel cell, but it's as well R&D, it is the methanization, growing project is the mobility through hydrogen or fuel cell cars, as well as the industry itself. When we look to the renewable energy in Germany, we see that roughly 3,000 gigawatt hours of electricity are regulated every year. That means the electricity could be produced, but it's not because of missing grid capacity. So the wind energy converters are turned off. Nevertheless, 300 million euros of compensation fees have to be paid for good reasons to the wind farmers. If we look to the hydrogen demand in Germany, we see that the industry uses hydrogen with an energy of 70 terawatt hours. This is more than 20 times more as we have to regulate from the renewable energy. So there's a big market for hydrogen, and electrolysis enables this market. H-TEC Systems offers two different products, especially for those hydrogen markets. It is our ME series electrolyzer with a rated capacity of rated power of 225 kilowatts, and it's our small stack, the Series S, which comes from powers to 1, 3, and 5 kilowatts. Here are some technical data from our stack. It is the S series S10, S3010, 30 and 50, which has rated powers from 1, 3 and 5 kilowatts. We can produce up to 2 norm cubic meters of hydrogen per hour with it. I won't go through every data presented here. The ME series is a big electrolyzer which comes with a 4-year performance guarantee. It has, as well as the S series, a very compact design. It is very reliable. We tested it very well. It can produce 100 kilograms of hydrogen per day and has a rated hydrogen output of 50 norm cubic meters an hour. The complete data sheet, as well as other information about our electrolysers or our stacks, is available at our booth at B54, and of course online all data is available, and I would really like to see you back on our booth to go through some details and elaborate a little bit on the possibilities that H-TEC could offer for your hydrogen demands. Thank you very much.
And thank you. If you could pass that on to Hector, who's waiting right there. Next up on the stage is Hector Maza, Vice President for Business Development at Generelx Inc. Welcome, Hector.
Thank you very much. Hello, everyone. Thank you very much for coming today. I'm going to try to be fast with the slides, not with the words, because I always get criticized for that. And before I start, I want to tell you we are at C47 for those of you who want to go more in detail in any of these slides. So for those of you who don't know about Generelx, Generelx is born out of Generelx Inc., which has been 45 years in the market. We've been a successful, profitable company ever since, focusing mainly in PEM technologies. Generelx becomes a spin-off machine. At the end of the day, we're spinning off 3 companies in the last year. The fourth one, which is on the bottom, was actually concluded today. And so I'm happy to say that that's becoming its own company, which is Generelx. That's alcohol sensing. I'm not going to go too much into it, but it's a PEM fuel cell that reacts to alcohol coming off of our skin. The most interesting part of Giner for me is obviously Generelx. I want to talk to you about that rather quickly. It's focused on large electrolysis for all the vertical markets that we have. Some of you know us from previous presentations at Hannover Messe, which is linked to the NASA or Department of Defense, nuclear submarines, etc. Today, we want to focus our attention towards the larger electrolyzers, not just the distributed hydrogen, which goes into laboratory hydrogen with large companies like Parker Hannifin, Peak Scientific, etc. So this is what the electrolyzers look like. A lot of you are familiar with PEM electrolysis today. We are happy to say that we still maintain, I think, the leadership in what is the highest efficiency at the lowest total cost of ownership. We are focusing on mobility systems. We're focusing, of course, on energy storage solutions. And these are just some of the trends that we've gone through in the last couple of years. We've reduced 70% the cost of the stacks and therefore about 30% the cost of the systems in the last 10 years. We plan to do the same in the next 5 years once again. This is just a brief history of where we come from the last 20 years. Now we're moving into the Allagash, which is the name of a river in Massachusetts, for those of you who are not familiar, which is a 1 megawatt DC current into the stack, producing 207 cubic meters of hydrogen. We are moving in the next 3 years to the next stack over, which is 5 megawatts. And some of you will wonder why so big. Well, just look around, look at all the opportunities we're hearing now from other competitors of ours, looking at hundreds of megawatts. We have been offered just Monday an opportunity to participate in a 500 megawatt opportunity. You cannot do that with 1 megawatt stacks anymore. You have to go higher and higher in terms of the current density and in terms of the active area. This is what a 1 megawatt stack looks like. It's now available. The 1 megawatt system is available. You can purchase this today from us, and you can make modules out of this. These are plug and play machines, ready to go. There's absolutely only water and electricity needed at the facility. Of course, we can also do customized integration. We have a variety of partners that we play with, and just to show the dimensions, it's a very small, for those of you who are familiar with alkaline, it has nothing to do with that. It's 15 times smaller. We are working with various integrators in different parts of the world, because if we're going to sell something in Germany, the German market has specific regulations. We'd like to act with a local player. If we're in France, in Italy, in India or whatever, we actually have local integration of our stacks into those systems. This is just to show the comparison between 1 megawatt and 5 megawatts. Again, we're looking at 2 tons per day in one of those stacks, a little bit over that. When we look at the whole mobility market, that's a half a megawatt electrolyzer right there, supplying to refueling stations for California. That's, of course, a Toyota Mirai. Some of you may be even driving one now. We're very excited this economy is finally taking off. Lastly, I would like to talk about the markets we're involved in. We talked about energy storage, we talked about mobility. We definitely are embedded in those, and now we have a very exciting project coming up in the Netherlands with the hydrogen turbine. You must have heard about it already. Some companies like the big wind manufacturers are very excited that now they can take more load off the grid and actually go directly into mobility. So they're going wind to mobility. We call it power to mobility. These are just examples of the most recent projects. You probably have heard about them, have seen them around. So again, the cost of electricity is the primary driver for this, because we depend on that to split water. So if you have available at your facility 10 euros per megawatt or 40 euros per megawatt, that's going to drive, every 10 euros is driving about 50 cents to the kilogram of hydrogen. The capex is no longer the biggest concern, it's actually OPEX. A full 10-year expectation is what most customers have. Some of them a 20 years expectation on the supply side of an electrolyzer. We expect to be able to change the stacks maybe once over the 20-year period, giving you the longest lifetime available. Again, it goes to the quality of water that you have. It's what you're going to expect. How long is this system going to be able to withstand without having to switch a stack? The switching of a stack takes 72 hours, so that's not an impediment, because that's a programmed change. Once a year, you have about 1 week that you stop the electrolyzer anyway for preventive maintenance, so you have 98% availability of this electrolyzer. This is just the inside of the electrolyzer. The outside of it, $4 per kilogram, so that's about 3.2 euros per kilogram. That's the goal. You can get that today with the right price of electricity, but in the larger installations, you can shoot for something much slower than that. Lastly, I want to leave you with this image. Today, boil off hydrogen costs about $8 per kilogram with a local installation from Air Liquide, Linde, Air Products, Praxair. That's what most of our forklifts are facing. Our challenge is to reduce that to something manageable under $5 per kilogram. That is what we're doing now. We're working actively with at least 2 of the major manufacturers to bring this to market for large, truly green warehousing mobility. And that's about all I have to say today. If you want to have more details for our electrolyzers, our technology, we are in C47, and we'll be glad to host you there and give you technical information or commercial information as you might have any questions on that. Thank you very much.
Thank you, Hector. You're up next. Next on the stage is Dr. Hans-Jörg Fell, who is, my notes here, CTO at HydrogenPro. Welcome.
Thank you very much. Hans-Jörg Fell is my name. I'm working with HydrogenPro, a company based in Norway. And as many of you probably already know, we have teamed up with the Tianjin Mainland Hydrogen Equipment, THE in short, of China. Together we are supplying first-class hydrogen plants to the global market. Only 5 minutes available. I want to start out with one question to you as our customers. What is the most important performance parameter when designing and deciding to buy a hydrogen plant? Well, it's not the sheer stack size, it's not the power rating of the stack, and it's not the performance of the electrolyzer by itself. No, at the end of the day, the performance parameter you have to consider is how much you pay per kilogram hydrogen produced. So it's the total cost of hydrogen production. And we are supplying high-pressure alkaline electrolysers, and I'm here today arguing that this technology is the technology of choice for hydrogen production by electrolysis, in particular for large-scale products. Our expert team with HydrogenPro and THE is your preferred partner for supplying hydrogen equipment. THE has been supplying these pressurized electrolyzers since 1994, and since then they have been supplying close to 400 units. This is a long, successful track record. It's a profitable company, and let us now look closer to the main advantages of the system. Well, as said before, size matters. Why is that? Because the specific investment cost for the plant is going down for larger units. We are offering the largest pressurized units on the market, 1,000 normal cubic meter per hour. That is equal to 90 kilogram per hour, equals to 4.5 megawatt. These can be supplied at high pressure. We are offering these plants with 30 bar. Smaller plants even can produce 50 bar, and that's both the oxygen and the hydrogen side. And the advantage of high pressure is clear. You simplify the compression step. For many applications, you can omit completely compression, and for the others, you simplify the compression step. This again reduces your investment and your operating costs. And furthermore, pressurized systems allow you to operate the plant more flexible. Our operational range is from 20 to 100%. But even more important, that has been mentioned before, energy consumption. It's a key argument. Taking in consideration typical power prices you will have here in Europe, between 30 to 50 euros per megawatt hour, you will have half of the cost of your hydrogen is related to the electricity. The final point I want to make here is the lifetime of the stack, and these are second to none when it comes to the alkaline systems. The overall investment cost of these systems is very reasonable. The system is modular by design and can be easily scaled up to large-scale plants. The technology, and that's the most important thing, we are living in a conservative world, the technology is proven. So, if you are curious about the technology and want to learn more about the technology and our team, please visit us at booth C48. And I'll be happy to answer any questions you might have, or contact me after this talk. Thank you.
We can actually stay on the stage because we're going to engage in a discussion now. Can I ask all the gentlemen to join us on the stage? So there are several issues that are mentioned en passant that deserve to be deepened. We have specialists here who can describe difficulties in spreading this technology. I'm going to refer to Hector. When it comes to debating whether electrical cars or hydrogen vehicles are plausible, he knows how much copper costs. It's simple things like that that often play a role. Also, recently in the United States, when I was there in September for the solar cell exhibit, there was a big discussion about how you actually refuel a hydrogen car. And there people learned that refueling a car involves getting permission from the local fire department to approve the nozzles and the device. So this shows you there are real challenges here. Europe does set some standards, but internationally we need standards. What are we going to do with the hydrogen? We have the renewable energy, we need to store it, but how is it going to be applied? When we look at the automotive sector, we have one very, very interesting prospect. That is the world's first hydrogen fueling certification in April of 2018. We have Nell Hydrogen to thank for that. Could you describe how easy it was to get everyone on board? This applies to all our technologies, by the way. This is not debate about which technology is better. It is a huge market if we move from simply servicing the grid to the automotive and transportation sector. So how easy was that?
It was very difficult. It took a long time, a lot of investment. You know, in the U.S., when we install hydrogen fueling stations, you know, we've typically in the past had to field certify every station individually. But now having that UL listing allows, you know, the authorities having jurisdiction a lot more comfort because they know it's already been, you know, it's a standardized design that meets all, you know, kind of safety and design standards. And they can, you know, in good conscience and comfort, you know, kind of approve it without a lot of extra, you know, kind of documentation and review.
Mm-hmm. So it is a success story, and it's very important. Genera has also broken a barrier of 750 euros per kilowatt, the price barrier. It's an interesting feat to perform. The question, though, it's the price of electricity also that we're competing against. Although, we could add, is it simply the price of electricity? If we have renewable energy and if we have policies driving clean air policies within the city. I live in Berlin, and factually, the apartments closer to streets with high traffic are cheaper because people die younger. It's a significant policy initiative now to either prohibit traffic in German cities, there's a big debate about that, or to get clean cars on the street. So when you see the prospects for your business, is it going to be policy-driven expansion, or are we going to fight the price of the kilowatt hour from the energy providers for the next 5 years? What's going to come first, Hector?
Thank you. I think it's a combination of everything. We have the policies on one side. We have some of these 20-year terms for feed-in tariffs disappearing, and now you have to exchange at maybe 2.7 or so cents per kilowatt hour, which becomes a real challenge for some of these wind turbine manufacturers. For us, that's great, because again, it becomes easier to justify the price of hydrogen vis-a-vis gasoline or any other petrol derivative. But at the end of the day, I think it's a combination of all these things. We do our part on the capex side of the equation, basically bringing down the cost, as we just said. But we also are contemplating all the carbon credits that are becoming available, and that is something that I think Europe has a lead on, and maybe Japan makes a big push on that as well. In the US, unfortunately, right now I can't brag about it because we are, I think, behind Europe, and we're trying to emulate some of the best practices both in the Scandinavian countries and Northern European countries, which are really addressing it. Let's start banning internal combustion engines inside cities. Let's start banning all these heavy trucks in the cities. And now, as you well know, France, Norway, Sweden, etc., have really made a statement in terms of legislation. I can only hope that in the Northeast, where we both come from, in California, which is really taking the lead for the US, we'll start looking at the total cost, and I'm talking environmental cost to the end user, to the customer, what should be reflected now into what goes into the equation of switching from not to electric necessarily, but fuel cell electric cars, and which is really a solution of zero emission. So again, we do our part. We propose this shattering this mindset of it cannot be cheaper. Yes, it can always be cheaper, and it only gets cheaper as we grow in scale. We think a hybrid solution between centralized electrolysis with the right price of electricity can certainly service 20, 30 gas stations nearby, and not necessarily always thinking of trucking from a methane reformer as we usually do.
It's very unusual for a Canadian to praise the United States, but let's face it, I was in California. The emission standards there are more stringent than they are in Germany. We had Connecticut here representing a group of people interested in the technology. They have very progressive policies there. So we have to get used to the way Europe is split up in different opinions. The United States also has its wonderful areas for this technology. But we still admire places like Japan, of course, because the Japanese industry has taken a huge role. Here they are with serial production of hydrogen vehicles. And there's something else interesting. It's almost sad to say Nell, who was the oldest member of the team, founded in 1927, has now been displaced by Asahi Kasei, which was founded in 1922. So the oldest player on the stage in terms of traditions, and a long tradition also in working with the electrochemical industry in developing this alkali device. Now, you're a billion-dollar player, and you have strategically decided to move into Europe, and you are marketing here an alkali electrolyzer. So what has attracted you to this market? It has to be a dollar and cents equation as well as the optimism for this technology. So what attracted you to Europe? You've set up shop. You're a European now in Dusseldorf.
Thank you, Brian. I'm European now. I've just started to live in this country from April. So, and as I said, Asahi Kasei Corporation has a long history, over 19 years. And so we have been working in chloro-alkaline electrolyzer at a very large scale. We have already installed gigawatt scale as a chloro-alkaline system. So we have base technology in our company. So we have developed this technology to water electrolyzer system. Because our company's policy is to realize the clean energy society. So we got to work to reduce the amount of carbon dioxide. So I think we should cooperate together because this is a very big issue all over the world. So this is work for our children and for our grandchildren and for our grandchildren. So we got to work to save the world, so save the earth. That is our motivation of Asahi Kasei company.
When I think of H-TEC, the PEM electrolyzers that you offer, this very humble approach to things, I add to that you're part of GP Joule, a group that has a solid dedication to integrating hydrogen systems and storage and renewable energy. They think very broadly about this. But this raises the question for me, are we talking about a prospect for hydrogen? I mean, the large source of wind energy in the north tempts us to think that we're going to get a big source. It's like an atomic plant. Then there's the distributed approach with smaller scale applications, and it seems to me that GP Joule is focused very much on thinking locally as well. Do you see a market for, let's say, less grandiose, more local, the sort of desegregated grid approach to applying to PEM technology?
Yes, of course. There are different approaches, and also the small scales are very important. When you look for the sector coupling, there are several industries who use gray hydrogen right now, and they are delivered by different companies, and they have to call them, and it's easy to substitute this gray hydrogen by green hydrogen if you buy the electricity from GP Joule, from Connect, or from whoever who delivers green electricity. And there's a market for the small scale. And especially since we work so close together with GP Joule, we also have a very dense focus on the electricity price. What you asked before, so are we competing against the electricity price? I don't think we do. We are competing against natural gas prices and to fossil fuels, because electricity has a very high charge on transporting. For example, we have one project in the north where we want to distribute hydrogen to fueling stations, and it would be the best to have the electrolyzer at the fueling station. But if we want to put the electricity through the grid to the electrolyzer, to the fueling station, we have to pay 10 cents per kilowatt hour. But if we produce it on site where we don't have the grid, we only have 1 cent per kilowatt hour in transportation cost if we do it on a truck. So there are regulations and the substitutions for fossil energy that we are competing with. And
when we were in California, and several of the gentlemen here were also in California, Björn Simonson managed to say something that I think everyone's jaw dropped in the public. We have the sense that renewable energy is forcing the business model. These people are just in the perfect position because renewable energies are non-storable. They come in the form of electricity. They are disruptive factors. But yet still, 1%, only 1% of the hydrogen consumed today is produced through electrolysis. And yet you have people thinking big. And here I'm focusing on Hans-Jörg here. You like the metaphors, Sleeping Beauty for the alkali electrolysis technology, although actually in Asian countries, they've been using it for quite some time, very, very successfully, maybe the European Sleeping Beauty. But the second question is size matters. And here you are working on large volumes. This means that the 1% of hydrogen that we are producing today has to grow. Where's the market coming from right now? I don't see fleets of hydrogen cars. Is the industrial demand increasing, or are we waiting for policy changes or a drop in electrical energy that makes mobile applications more affordable?
Well, probably a combination of all, and this depends also where you are in the world. The current market, I think it's fair to say, is predominantly traditional industrial applications. THE has now signed the largest contract in the company's history, and probably also the largest contract in China's history, supplying 4,400 normal cubic meter per hour plant. This equals to 20 megawatt. So this is a pretty large size. The units which they are supplying are 2 times 1,000 normal cubic meter and 4 times 600 cubic meter. This delivery will be shipped to northern China, close to the Mongolian border, and the customer is a producer of photovoltaic panels. So this is the traditional industry where they need clean hydrogen, and electrolysis is the method of choice. Then we can see that we eventually will also replace fossil fuels. We have the European Renewable Fuel Directive, which opens for synthetic fuels. And I think this is the next big potential where we can use hydrogen, CO2 captured from any industrial source, and then produce synthetic fuels. There we have a collaboration with Mitsubishi, Hitachi from Duisburg, looking specifically at those projects. Also here we require a huge amount of hydrogen, predominantly in areas where you have low electricity prices. And I'm thinking about areas like in Norway, where you have electricity prices close to 20 euros per megawatt hour. So this will be a trigger point, and related to this installation, you will also be able to have a side stream supplying the automobile sector with hydrogen at a very reasonable cost.
And of course, all gentlemen are invited to add to each point as we progress in the discussion. I always am happy to have specialists in the field on the stage because there's so much information that you just don't understand. For instance, here we have a high pressure alkali. I believe we have an atmospheric pressure alkali. We have Siemens, who just launched a PEM electrolysis device. They work at atmospheric pressure. Okay, so what are they thinking? What is really the advantage or the disadvantage of this, or does it depend on the application? Atmospheric pressure. What's the difference?
I'll take a stab at Siemens as usual. No, actually, I think that Siemens has changed their strategy 2 or 3 times already. I think that they're following now the typical example of our old alkaline friends, which they have always done atmospheric. It happens to be simpler to do atmospheric because there's a penalty when you compress electrochemically. Both of us have been compressing electrochemically for some time, and it turns out we find it easier for our customer to take in already 40 bar or 30 bar or whatever from the start off, and then some of that water already drops off. I think in the case, and then you can do 2-stage compression instead of 3 or 4. So you're saving something in that process. But at the end of the day, I think that Siemens went in one direction first, realized that the efficiencies and other things, or maybe the costs were not there, so they changed completely a U-turn now. And you mentioned it well, they're announcing a different, complete different stack, complete different architecture now, going back to atmospheric, reducing current densities again. We'll see where they end up in cost. I don't think they're necessarily chasing the market so far until the market for them is a multi-billion euro, I'm sorry. But in our case, we are happy to continue to lead on the technology side and continue to grow with the market. And unfortunately, at some point, and I've said this before, yes, size matters, as you said. I think we were talking about that last year. When the wind guys decide to go, and they're now deciding to go forward with diverting tens and hundreds of megawatts into electrolysis, I don't think all of us together will be big enough for that market. But in the end, I think a company like Siemens can get serious about it tomorrow and decide in 3 years, 4 years, I'll catch up with these guys in terms of technology and have that size as well. At this point, we are more concerned about making it happen in a very small footprint to fit into your European cities for mobility. And later, you can have centralized locations that will drive in that hydrogen to each one of those locations nearby. And then it's just going to be a run for capital. And I think working capital will be the name of the game. Technology, all of us have various approaches to it. In the end, is going to be who can actually build it fast enough.
Yeah, just to echo what Hector said about the pressure output. It's a cost trade. I mean, we've been selling, pressurized PEM electrolyzers for many years, and for the most part, our customers say 30 bar output pressure is pretty good. I mean, for most of the applications that we're serving, it matches up well with a lot of industrial compressors, and it also addresses some applications where you may not even need compression. So it's a cost trade. I mean, you could go higher, but if we don't see the value for it, we won't.
Yes, the same holds true for H-TEC. We see also with 30 bar is a pretty good value. If you want to use hydrogen for mobility, it's pretty easy to compress it further. On the other hand, if you need on-site generation of hydrogen, you could easily distribute it to your pipes, your lines, your application. So 30 bars is certainly enough, so it makes it flexible. You don't need a compressor for every application, but if you need one, it's you save one stage. So it's the most flexible. But on the other hand, it's of course the higher you go in pressure, the more the designing you have to make. It has the cost of the stack increases. There are also 200 bar stacks available, but they're really solid, and it's pretty expensive if you don't need the pressure in the moment. So it's.
If you have a closed cycle here, let's say a remote application, so you generate hydrogen, what pressure does a PEM cell expect in order to convert it back to electrical energy? Any takers?
We start out at 40 bar. That's what we do in the differential pressure. But now we are having more and more people like Department of Energy coming and saying, can you do electrochemical compression? Because compression is being the real showstopper in terms of having an electrolyzer working 98% of the time versus working 60% of the time. We have compressors that every now and then have to be stopped and have to be changed for seals or for whatever else. We are now in that process of developing a very large electrochemical compression up to 900 bar at 3.7 kilowatt hours per kilogram efficiency levels. And we're driving it down. Of course, breaking the barrier of 3 will be very hard, but that is where the industry wants us to go. We'll try to do that for a solution, not just for us, but with anybody else. Our PEM electrolyzers happen to have that virtue of differential pressure in the stack. We standardized at 40. We thought that was a sweet spot. And we've done it at 80. We've done it at 120 bar. But we think that the right, I would say, the optimal point to not increase the cost of the stack so much and actually get also the productivity levels that we want, it would be around 40 bar. I couldn't...
I get that, but the specific question is, what does a PEM cell, we're talking about fuel cell, not electrolysis. What does a fuel cell expect? Does it need 40 bar or 30 bar?
No.
So you don't need to pressurize unless you're thinking about storage?
No, you don't need the pressure in the intake, but every time you work with a fuel cell, if you can provide pressurized hydrogen and oxygen, you can actually get higher efficiencies. And I'm not a fuel cell expert, but I guess my colleagues here will corroborate that as well.
Okay, we'll pass it on to Masami, yeah?
I think the important thing is not whether pressurized or atmospheric, but the most important thing is, as Hans said, the price of production cost. So if we can produce at a very low cost by using pressurized technique, we should use. But if we pressure after electrolysis, it is lower, that we should operate at atmospheric pressure at a large scale. Then we can use a compressor to make a high pressure. So it depends on the market demand, and also it depends on the customer's demand. And the most important thing is the production cost of hydrogen. So the level of pressure varies by customers. So we have to fit our price and process to the customers in market. That is the most important thing, I think.
Yes, so it holds true. If you put pressure on a fuel cell, you would have a somewhat higher efficiency, but it doesn't really matter. So most fuel cells, they operate roughly at atmospheric pressure. But the thing is, you have to store the energy or to store the hydrogen. You don't want to produce hydrogen and use it directly in a fuel cell. It doesn't make sense. It's just the heat generation. So for intermediate storage, it makes sense to have also a 30-40 bar tank and use it afterwards, or even bigger tanks or higher pressure if you need some long-term storage.
I see when I look on the stage that you almost have to stress the nature of these gentlemen related to where they come from, simply because we have two representatives from Norway there. So if you happen to have an electric car, how much does it cost to tank it there? 0. Okay, there is a direct commitment of the government because they produce so much electrical energy. It's hydroelectric energy, it's environmentally clean, and their policy of storing energy is very aggressive because they have the kilowatts. It's a fundamental commitment, and why industries grow up in those countries, maybe it's historical, but certainly right now you can see, wow, is it an interesting thing. This somehow relates also, though, to the Japanese situation. I was talking to your colleague on stage yesterday. We have lots of renewable energy. We have to store that renewable energy. You know, it's a source of hydrogen. It could power the vehicles there. Japan is already manufacturing fleets of cars. So I asked your colleague, well, where are they going to get the hydrogen from? And he said, we'll import it. Is this true?
Because Japan has not don't have enough renewable energy at the moment. So our Japanese government policy is, as you said, we will make cheap hydrogen outside Japan, and we will import the hydrogen from outside Japan. So this is bad, but I think we did this in liquidization natural gas because we are importing a lot of LNG from outside Japan, and that is used in Japan. So that is one possible. But in that case, we need to reduce the transportation cost, of course, and also we have to get very cheap electricity outside Japan. So if that is economically feasible, that might happen. But it's I think in the future. So now we have to get renewable energy at first.
I say this because we have a number of people who think globally, but I've never. When I say globally, let's export electrolysis equipment, let's export our PEM cells, but let's export our hydrogen. Is that an entirely new message? Have you ever come across that before, Stephen?
Yeah, I mean, I think it goes back to that slide I showed of the Lockheed tanker boat from 1977. That concept of exporting hydrogen in different forms, either liquefying the hydrogen or converting it to ammonia. One of the more promising opportunities for Japan is making the hydrogen in Australia and either liquefying it or turning it into ammonia and importing it to Japan that way. So I think it's real. I mean, you're always going to have parts of the world that are energy rich and other parts of the world that are energy poor, and somehow a market will develop that exports that energy between those two places.
I should add that if there's questions from the audience, we will have time to take one or two. If you just raise your hand, I'll bring you. Oh, we do. I hope you don't mind, gentlemen. We'll take a few questions from the audience.
We talked so much about the technical aspects, but I would like to hear more from you about the triggers that would be needed. The triggers that would be needed in Germany or in Europe or worldwide to support the electrolyzers. I mean, what's needed? What do you need in future from the government, from money-wise, from whatever, to get more business, to become more attractive?
If I hear that correctly, I take it first. I'll pass on the mic in a second. I think it's being done right now. What's needed is to have the true cost of any fuel you have, total cost of the fuel, with all the carbon impact that it does evoke all the way from birth to wheels. And once that's taken into account, which I think I said before, the Europeans are taking the lead on that, then you can really be extremely competitive with hydrogen and even other alternative fuels. So we are very much looking at Europe and the European example to bring hydrogen to the US, to Latin America, to even Japan. Japan has a totally different scenario where their electricity cost is so high that electricity becomes a premium to do electrolysis. And then you have to really get creative, like Steve just mentioned, going back from Australia where you can have cheaper electricity, make massive amounts of boat it over to Japan. But in the case of what has to be done to grow our market, it's already happening. We have now super low cost of electricity available to us from renewables. So 1 cent, 2 cents, 3 cents per kilowatt hour, which translates to half a euro, 1 euro, 1.5 euros of electricity content into the kilogram of hydrogen. The rest is capex. What we're doing is making capex last long enough so that you amortize it over 20 years and make a very cheap molecule of hydrogen delivered at pressure for the consumption of the electric vehicle, but not only for the fuel cell electric vehicle, but as well for whether you want to do power to product, that was mentioned here before, but even energy storage, so power to power. So I think everybody's working in tandem in that direction. It's a matter of having the right incentives and the total cost of ownership of that fuel which is coming to your vehicle today.
Yeah, and I'll just say that that feeds to a business case for this, because right now we talk about all these different use cases for hydrogen, but there's not really a lot of them that can actually make money. So I think that as we drive down the cost, the total cost of of hydrogen, I think it'll help with the business case. I mean, today, all the power to gas projects are basically subsidized because they have to be. I mean, you just can't get private investment to build these projects.
I think this in this way, what would help really a lot would be a fair treatment of renewable energy and fossil energy, so that fossil energies should pay the taxes as well as for renewable energy per kilowatt hour. So if you take natural gas or coal or whatever and don't pay it per kilogram or per kilowatt hour and the same tax for renewable energy, then we would be there.
Let me just say one more thing. Do you have a clue of how much goes into subsidies in the US, and I'm shooting at ourselves now, for the oil industry to just do exploration and drilling these days? $20 billion per year, subsidies, because they really need it, because they're very poor companies, right? So the moment that we decide to divert maybe $1 billion towards hydrogen, we're done. We don't need any more. We can actually start growing at that. And when you make one car of hydrogen, it's going to cost $1 million. When you make 1 million cars of hydrogen, it's going to it's like we see today in the internal combustion engine industry.
Yeah, my question is on the solar industry also has seen such things over the last 100 years, and it has grown to be a very successful industry now. Same way, hydrogen to grow, policy support from governments is very important. And how far the political maturity has come in countries to support because there is a lobby, fossil fuel lobby, to overcome that, hydrogen to come. How much is the political maturity level? And because the investors have to understand in how many years it is going to mature. Based on that, we can plan our investments. So what is your understanding in how many years it is going to be like solar today?
Well, it just meant the renewable energy systems thinkers are, of course, JP Joule and H-TEC. Do you want to try that question?
Okay, could you just compress the question shortly?
Well, I understood it as a question on the big success story of solar energy people are informed of, but we have, as mentioned before, subsidies of the oil industry. We have to not simply compete, we have to subdue their advantage. We have to, force the advancements of our own technology. How do we do that?
Different approaches. Just one key issue is a learning curve, as we also have had in the photovoltaics. If you look back from the beginning of photovoltaics, there was extremely expensive, maybe like 30,000 euros per kilowatt. Now we're down to 500 euros per kilowatt. So we can do the same with electrolysis and every kind of renewable energy. The key is just a learning curve, mass production, and then we come down to the costs. Already now, really close to the costs of fossil fuels, or so it's really very close to the break-even point, and then once we have this break-even point, we'll get cheaper with renewables and storage, and then everything will catalyze itself. So that's the way. Mass production, price goes down, and then we're done.
Mm-hmm. I think all these gentlemen, I've done this for, I think, 4 years running now, and they all hate me because year in, year out, I expect them to solve the environmental issues. They're supposed to show up on the stage and say, okay, we have the renewables, I'll store it for you, and when you need it, just plug in. It's not that simple, and it's not that simple for many reasons, of course. There are intermittent stages. You can reform natural gas, and by comparison with other hydrocarbons, it's not that dirty. It's hard to launch an argument against environmental policies that begins with attacking high-octane natural gas. The only thing is there's energy dependency. Germany is entirely dependent upon imports. So here we crunch the numbers differently than the people in Norway do, because we literally can be shut down in Germany. The Germans don't talk about this very often, but the political dependency is a monster issue. The Americans would never put up with it. This makes it a volatile situation. And one of the ways around that is to create a secondary natural gas grid. Methanizing hydrogen would be one possibility. But this is a monstrous project because the electrical energy consumption 15% maximum of the overall energy consumption in Germany. I think Hector already wants to jump in here.
I can't respond because I don't have a crystal ball. So how long would it take? Nobody knows. But what we do know is that every 4 years we have a slight turn in the politics, at least in our country, and we know that that it's highly dependent on lobbyists. Absolutely. I think when you reach a critical mass of we're talking about less than 1% of a hydrogen being produced right now by electrolysis. The moment that you start getting 1 to 2% of that, the economies of scale kick in dramatically. I mean, you can't compare an internal combustion engine, which is over 100 years old, even a battery vehicle today. And to name one thing about battery vehicles, which fuel cell electric vehicle is also an electric vehicle, you look at lithium and you say, wow, maybe we need an Elon Musk on this side of the equation, on the side of hydrogen, to speak for us, because when you start analyzing carefully what the electrical vehicle is going to be facing in the next 10, 20 years, it took us, 100 years to build the infrastructure we have today for fossil fuels. You cannot expect that in 2 or 3 years you're going to have the refueling stations everywhere, at least in the US, 200,000 fueling stations. But you start with fleets, you start reducing the cost of the fuel cell vehicles, you start reducing the cost of electrolyzers as well, and very soon you gain a critical mass when everybody starts realizing, well, guess what? This is actually cheaper total cost of ownership than what we've been doing for the last 100 years. Lithium, unfortunately, you have to mine it. It costs not just money, but also carbon. Then you have to extract it, put it in a battery form, and then use it for 2,000 cycles and then throw it away or recycle it. That, unfortunately, is not sustainable. And even if you were able to do it at the current rates of mining, it would take us 360 years to get all the vehicles turned over to batteries. You can't do it. So it might be a bridge towards a hydrogen fuel cell vehicle, but it's the end solution. So I do disagree with Elon Musk, but we need somebody like Elon Musk on our side of the equation, advocating for us, lobbying for us, and helping us just get to that critical mass.
This reminds me of Toyota, who had a cooperation project with an American electric car manufacturer to work on the batteries. They put that. Very important decision. It's a strategic commitment to hydrogen as opposed to the battery as the easier technology. Perhaps when we talk about growth and interim phases, we have a number of people who do nothing but number crunching research. Jülich is a huge, what they call a Forschungszentrum, that is a research department. All they do is the number crunching there. I had this wonderful PhD student up on the stage, and he said, okay, we have all this wind energy, we can convert it to hydrogen, but what are we going to do with it? And you would think, well, it's going to be everywhere. And he said, no, let's go to the highest bidder. Let's sell it to the people who operate Munich. That is, these are businessmen. In the interim phase, you have to find a good price for the hydrogen in order to develop the business. I mean, someone said here it's going to take us a long time to develop all of the resources to harvest renewable energies. You have to build all of these and we're not there yet. You can't answer to all the demands. How long is that going to take? The interim phase is interesting because in order to develop the business, you have to find the market, hopefully a renewable market. And this guy said, no, you should put it in a train and send it down to the south of Germany and use it there in the buses. In the interim phase, so this is a direct question because you do know your business models, you people. Where is not the business model now? We saw the slides from Hector. We can see what he's doing. But where is the business model in 5 years? All of these people represent growth. The electrolyzer industry has never occupied so much space on this fair as in this year and the last year. They are booming, and there has to be a reason for it. So where's the business?
Yeah, I mean, I'll just say, for the next 5 years, I think it's going to be focused on transportation. And I think there's going to be a lot more activity in the heavy-duty sector. We're seeing that quite a bit in the U.S. So I think, light-duty vehicles, they're coming to market, but we're seeing, heavy-duty and transit as being a real growth opportunity.
Mm-hmm. Masami?
So I think in 5 years, the transportation sector is the most important market for green hydrogen because there is a lot of activities going on, and also regulation will support the transportation sector. So, but in the future, we got to prevent our climate change, and we have to reduce the total amount of carbon dioxide. So we need to go into the power to gas market, and so this is a very huge market, and not now, but we will go on to the area. So we need to brush up our technology and to reduce the cost. Otherwise, we cannot prevent, we cannot meet the Paris Agreement. So for initial stage, transportation is okay, but we have to find the large-scale market. We work together, I think. We need cooperation.
Hans-Jörg, where's your future business 5 years?
Well, I think it's clear from, again, depending on which country you're in, but in Germany we have heard the success story of Alstom train. So the hydrogen train is coming certainly, and that requires substantial amounts of hydrogen. So my prediction is there will be built several large hydrogen plants for that purpose. You look at the Netherlands, where they have strategies to produce hydrogen either for buffering renewable energy or to produce hydrogen for the chemical sector. And then this brings me to the sector coupling, where we also see, I think we will see the first big plants being built in the next 5 years, harnessing renewable energy, maybe combined with water, hydroelectric power in Norway to produce hydrogen either for the chemical sector or other sectors as well.
And of course, you at H-TEC with JP Joule, you do the whole gamut from biofuels through to hydrogen fuel cells. But in terms of your market, where is it coming from in 5 years? Do you see the growth potential that everyone else does here? Do you understand the hype surrounding electrolysis right now?
Yeah, it's as my competitors or my partners here said, it's ability, it's a sector coupling, and the market is growing. The car industry comes into place, and they all need hydrogen for their cars, the trains. The market is developing. The demand is increasing, and our possibilities are increasing. Prices go down, so it matches. So we have clear predictions that the hydrogen market will grow, and it has to be renewable. There's no way out of it if we want to reach zero fossil fuels in 30, 40 years. Mm-hmm. So it is only hydrogen, and we're putting money on that horse, and it will certainly win.
I'd be happy if my longevity wasn't shorter, because I live in Berlin, actually. So I have entirely different goals here. A historical Rückblick, as they call it in German. 2004, when I was here, people were announcing that within very few years there'd be 100,000 hydrogen-driven cars on the highways. Very optimistic. I think it was at least 6 or 7 years ago that people were talking about filling all of the empty salt mines with hydrogen. We would be harvesting all of the North Sea energy there. Gigawatts would be stored. We could run the country with the stored hydrogen there for months at a time. The interesting thing about all of these things is they may still be true, but we just screwed up the time scale. But the important thing is, in terms of renewable energy, every year I ask all the physicists here, I ask all of the people who in the energy large scale in Germany, if there is an alternative to electrolysis and hydrogen storage in order to reap the rewards of renewable energies. And what do they say? Is there an alternative to electrolysis and hydrogen storage? No. As far as they know, there is no alternative. These people are sitting on the cusp of a potentially very large development. I hate to make them responsible for our future and our clean air, but this is, I think, the fascination with this branch. It's a fascinating technology. We haven't dealt with all the controversy, but we'll be seeing all of these gentlemen hopefully next year. Continue the conversation. I'd like to thank all of our guests on stage here. I've been talking to Stephen Szymanski, who's business director at Nell Hydrogen, and Dr. Masami Takenaka, who is from the Clean Energy Project and managing executor of Asahi Kasei Europe, for the first time here on the stage. So to you again, Dr. Frank Allebrod, who's head of R&D at H-TEC Systems in Germany, Hector Maza, who is vice president business development at Ginner. I did it right this time, Elex Inc. And last but not least, Dr. Hans-Jörg Fell, CTO at HydrogenPro. It's been a pleasure talking to you, gentlemen. Hope to see you back here next year.